In this section, I would like to facilitate the process of learning to understand where the water generates some qualities that we would say for it, it is the universal solvent. So far, we have seen a couple of things that came from the molecule of water. Firstly, we've seen the union of single oxygen and two hydrogen atoms through covalent bonding, sharing pair of electrons, generating a molecule of water. Then we interpreted, because the molecule is slightly asymmetrical, that electrons that are orbiting around oxygen and electrons orbiting around two hydrogen parts of the same molecule do not spend equivalent time together. So part where the oxygen is attracts electrons a little more, making it negatively charged part of the molecule. And then parts where hydrogen atoms are added, they attract electrons a little bit less, and we name this as the more positively charged part of the molecule, which is essentially considered polarized. So all of us have done simple things such as taking a teaspoon of salt and putting it into water, trying to prepare some kind of meal for us. And within a couple of seconds, we would see that salt actually dissolved in water. We are absolutely aware of that, and we know if we try, we take the same sample and we sample it, the water will be salty. It would not have a neutral flavor or no flavor. It will become salty because obviously the table salt has been dissolved. Let's find out what is the chemical process behind it and how water really generates to this level that it became the universal solvent. Let's share the screen and one of the slides that we have in our textbook that illustrates, firstly, water molecule with its more negative and more positive ends as the water molecule is polarized. Now, we would need to go even one more step back in order to think about ionic bonding, which we witnessed between ions of sodium and chlorine as they form the crystal of table salt. We know that sodium donated, the chlorine accepted donation of one electron, so they both turn into their ionic form, sodium being positive, chlorine being negative, and of course that kind of electrical positivity and electrical negativity was attracting factor to bring them together. But they're held together just like electrically. That means if you interpose another substance between these electrically charged ions of sodium and chlorine, basically it is going to break the bond. So we're using the polarity of the water molecule to interpose it in between sodium and the chlorine ions. If the sodium ion is positively charged, it will attract, as illustrated on the upper part of the picture, negatively charged parts of water molecule. So that is going to practically separate electrical positive sodium ion from anything else that carries the electrical negative charge, like ion of chlorine, because it is already surrounded by multiple electrically negative charged parts of water molecules. For the chlorine with negative charge, of course, because it gained one extra electron, it is going to attract water molecules around it as well, except that it will be attracting those more positively charged particles. So again, the chlorine, instead of aiming for a single sodium with a single positive charge, now became surrounded by multiple water molecules in their positive parts of the molecule exposed to it, practically being separated from the sodium. That is how water managed to dissolve the table salt, its crystals. What would happen to table salt if you continue boiling the water on a hot stove until it completely evaporates? Basically, it would leave at the bottom of a utensil that we use for cooking very thin layer of crystals of table salt, because through the process of heating fluid we evaporated molecules of water, and of course we enabled sodium and chlorine ions to essentially face each other, to establish their electrical attraction, and to form crystals of table salt.